Our objective for today, I can simplify exponential expressions using the multiplication properties of exponents. Let's read together. 1, 2, 3. I can simplify exponential expressions using the multiplication properties of exponents. So, according to the question, it says, what is the concept for today? Tell your neighbor what the concept is for today. And of course, that goes in the FAIR model, right? Or in the box that you guys call it. So write that in the center of your FAIR model, exponential expressions. And today we're starting with those expressions, and we're focusing on multiplication properties today. I'm going to move the screen, and if you haven't copied the objective, you know it's always on the board. However, let me get started. Exponential expressions, what are they? Exponential expressions are a numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical variable expression raised to a power greater than 1. A numerical variable expression raised to a power greater than 1. Tell your neighbor the definition, please. Bam. You guys are pretty good. So check this out. Writing utensils down really quick. Let me go over the definition by writing the example. I'm going to first do it like that, and then I'll give you time to copy the rest. It says, a numerical or variable expression raised to a power greater than 1. Look at this first one. They're only using numbers, therefore this is a what? Numerical expression. Raised to a power greater than 1? Yes. Look at this one. They're using a variable, so what kind of expression is this? A variable expression raised to a power greater than 1. This one has a combination of numbers and variables. However, I cannot just call it a numerical expression because it has a what? A variable. Therefore, this is a variable expression raised to a power greater than 1. And the last example, x squared y cubed, variable expression, power greater than 1. Everybody see that? Copy that, please. All right. So now look at the none examples. I'm going to give you 3 none examples, but first I'm going to give you 2. Check this out. Look at these 2. You can copy those, and as you're copying them, say, these are not exponential expressions because something very obvious. Okay? Okay, we got that. Now let me give you the third one. This third one is not an exponential expression because of this and because of that. It's 2 different things that makes it not an exponential expression. All right, now that I gave you all 3 of them, talk it over with your neighbor. Why are these not exponential expressions? All right, I'm going to take a volunteer for the first 2 none examples. Why are these 2 not an exponential expression? Go ahead, Jeremiah. Because they have an equal sign. Therefore, what are these called if they have an equal sign, everyone? Equations. And right now we're looking at what? Expressions. And now, to differentiate one from the other, we will get there so I can clarify it, but let's see if your teacher showed you that last year. Last year, they should have told you that expressions can only be simplified, whereas equations can be solved. Is that correct? All right. Let's look at the last non-example. Jeremiah, pass it to someone. Why is this not an exponential expression? Who? Brian. And there's no power. That's one thing. What's the second thing? Why is it not an exponential expression? Pass it to someone so they can help you.
Because it doesn't have an exponent, and because it has a plus sign also.
It has an addition. Does everybody see that? This one is being added. And what are these? What's happening to these? Only multiplication, so it only applies to multiplication. So what is the most important thing to remember about exponential expressions? Oops. Hashtag what? Okay, hashtag expressions only. And hashtag, what is the second most important thing? If we say expressions only, that excludes equations. But what is the other property, most important property? Right? Exponents greater than 1. Or powers greater than 1. Got it? All right. I'm going to give you steps so that you have, keep in mind what we're going to be doing, and also so you can see all three properties. But today we're only going to focus on the first one. But here goes the steps. Here goes. Steps. Number 1, identify if the exponential expression is a product of powers, power of power, or power of products. Step 2, use the appropriate property to compute. And step 3, simplify. Step 1, identify if the exponential expression is a product of powers, power of power, power of products. Step 2, use the appropriate property to compute. Step 3, simplify. Step 1, identify the exponential expression as a product of powers, power, power, power products. Step 2, use the appropriate property to compute. Step 3, simplify. Copy that, please. Today we're going to focus on product of powers. Product of powers, and I'll show you what that is. Before we get started with the property, I want to talk about two of the properties that you've been using, but I also want to remind you about this. Look up, please. Whenever you see a number without an exponent, automatically I want you to write a 1 as an exponent. Whenever you see a variable without an exponent, what are you going to write? A 1. Whenever you see a negative without an exponent, what are you going to write? A 1, and so on and so forth. Now, there's special situations with negatives, and I'll show you that when we get there, but for right now, just keep that in mind. Now, on the Q column, everybody see the Q column? I want you to write commutative property of multiplication. Leave a space underneath that, and then you're going to write associative property of multiplication. And these properties, I'm going to cover these just to emphasize on something that we're going to do in a little bit with an example. Yeah, on the Q column, that little rectangle, it fits in there, right? These properties you've been using since you were in 3rd grade. They introduced it, I think, in 3rd grade. But they never really emphasized on them until you got to 5th, 6th, 7th grade. And now we're going to continue emphasizing on them. Okay? Now, let me clarify what each of these do. Commutative property of multiplication. The word commutative comes from the word commute. Who's heard of that word before? Okay? Now, let me use it in a sentence for those of you that don't. It's not really clear. There are teachers that commute every day from Yuma to Imperial to come teach at Frank Wright. Okay? Also, this weekend, family of mine, they commuted from Imperial to San Diego and back. So the word commute means what, everyone? To travel, right? To travel or to move or whatever the case. So therefore, that has to do also with mathematics. Watch. Let me use numbers so you can see commute. 2 times 4 times 5, because it's involving what? Multiplication. Commute means that I can move numbers. They can travel from position. But the product will remain the same. So watch. What is 2 times 4? Times 5? Okay, so now let me make these two commute. 4 times 2 times 5. Let's see. What is 4 times 2? Times 5. It's still the same product. That's all it says. Now, can I move the 5 and the 4? Yeah. I can do like 5 times 2 times 4. What is 5 times 2? 10 times 4. It's still 40. So that's what the commutative property of multiplication says. As long as there's multiplication throughout, you can move stuff around and the product will remain the same. Everybody got it? The second property is the associative property of multiplication. 2 times 4 times 5. How this works, this word associative comes from the word associate. Have you guys heard that before? Okay, for example, let me put it this simple. You guys have a group of friends that you associate yourself with, yes? But every now and then, there's friction in the group. I'm not saying that you guys are the ones. I'm saying in the group. And all of a sudden, they exclude one of you. And then these two associate with them, and then they exclude this third person over here. Well, the associative property of multiplication says it doesn't matter how you associate the numbers, the product will remain the same. 2 times 4 times 5. And of course it happens that after a while, these two get upset, and guess what? Does that make sense? You see what I'm saying? So watch. What is 2 times 4? 8 times 5, that's 40. Over here, what is 5 times 4? Times 2, it's still 40. So it doesn't matter how you associate the numbers, as long as there's multiplication throughout, the product still remains the same. So you're saying, I never noticed that. Then you're probably the one that they don't want to hang out with. Anyways, any question with those two? We're going to be using those two today. So, turn your paper over, because you're going to need more space. And in the back, you're going to write product of powers property. So, here goes the property. Example Q. So, write this down. 2 times 2. Underneath that, you're going to write 2 times 2 to the third. Underneath that, you're going to write 2 to the third times 2 to the fifth. And whatever example I give you with numbers, I'm also going to give you with algebra. So over here to the right, I'm going to write x times x. The next one would be x times x cubed. And the next one is x cubed times x to the fifth. So, the simplest thing, what did I say whenever you saw a number in a variable without an exponent? Put a 1. So 1 here, 1 here, 1 here, 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 and here. Very important, guys, because I can assure you, if you don't take care of these simple things right now, as we move along to polynomials, they become a bigger problem, okay? All right, here we go. So, those are the examples I'm going to use. So now I'm going to show you the property. I'm going to stay quiet, and your noodle's going to do all the work. Okay, this is the year that you're going to be doing the work. All right, here it goes. I'm just going to guide you. Pens down, writing utensils down, eyes on the screen. Here it goes. And let's see if it works with the rule that your noodle got already in. Before you copy it, talk it over with your neighbor. What would be a rule for that product of powers property? Talk it over with your neighbors. All right, copy that, and then I'll ask for somebody to start us off with a definition. Go. So, let's write our like a definition here. In the center, put an asterisk, and then draw a heart, so we don't forget. And this lesson, what was the title for the lesson? Let's see, what did we have? Multiplication properties. So what operation are we doing with these? Multiplication. So let's start it off when multiplying. When multiplying what? What are we multiplying? Yes? Okay. What are they called? Hannah? Okay. A more formal term. Christine? When multiplying exponential expressions, that what? Who can help me out with the next? Yeah. That have, or what was the word? Share the same base. Share the same base, comma. Who can finish it off? Yes, Chelford? I add the exponents, period, and then 10q. Let's see if it makes sense. When multiplying exponential expressions, are we multiplying exponential expressions? Yes. That share the same base. Do they have the same base? Yes. I add the exponents. Does that make sense? Yes. 10q? 10q? Yeah. 10q? No? Never mind. All right. Now that we have the rule and the definition, now let's kick it up a notch. Let's do some practice, but now I'm going to mix it up a little bit. Here it goes. Example, super Q. 2 to the 4th times x to the 5th times 2 times x to the 6th. So, the very first thing we should do is what? Tell your neighbor, please. Very good. A lot of you started saying all these intricate things, but it's like, put a 1 on the 2. Right? Yeah. All right. So, to get us started after that, we need to get all the numbers together and all the x's together. Tell your neighbor what property we're going to use to do that. Commutative property of multiplication is going to let numbers travel. So I'm going to travel this one here and this one over here. Therefore, this is 2 to the 4th times 2 to the 1st times x to the 5th times x to the 6th. All right? Next, to group them, we use what property? Everyone. Associative property of multiplication. All right, so this becomes what? 2 to the
This,
5th power times x to the
second, no, 11.
11th. All right. Up to right there, we're done. Except for, I wanted to kick it up a notch, and I'm going to ask you to simplify, which means I need to expand this one, 2 times 2 times 2 times 2 times 2.
I got
Everyone?
32.
32x to the 11. And now it's completely simplified. Okay? How are we doing? Yes? 1 being the lowest, 5 being the highest. Show me how comfortable you feel like with product of powers property. I got some 4s, some 4s, some 4s, some 5s, 4.5s, 4s, 4. Some of you have weird fingers. Some 5s. All right. So let's do some practice so we can get more comfortable with these. Yes? Yes, Mr. Q. All right, good. Copy these, please. Example 1A and 1B. It says simplify. Example 1A is 3 to the 2nd times 3 to the 5th. I want you to first write it as an exponential expression, and then from there simplify it to lowest terms. Same thing with B. 2 to the 4th times 3 to the 4th times 2 to the negative 2 times 3 to the 2nd. Bless you. Copy that and go. All right. Example 1A. What would be the exponential expression for example 1A? Let's see, help me with that one. Charlotte, what would be your exponential expression for this one? 3 to the 7th power. Hands if you got that. Okay, but then I said 2 lowest terms, you simplify, yes? Which means you need to expand 3 times 3 times 3 times 3 times 3 times 3 times 3, which is 9 times 9 times 9 times 3, which is 81 times 9 times 3, which is 729 times 3, which is 7, 2, that's 6, 8, 3, 21, 21, 87. Yes? All right. Finish up B, see what you get. What is our exponential expressions for B? 2 to the 2nd times 3 to the 6th. Hands if you got up to right there. That is correct. But since I'm asking you to simplify to lowest terms, pass it to someone, Axel. Felipe? What'd you get for B? You haven't finished? Okay, we'll wait for you. All right. $733. Hands have you got that? Close. So watch, Felipe. 3 to the 6, here's 2, 4, 6, which means up to right here it's 729. But instead at the end multiplying times 3, what do we multiply by? Times 4, because this is 2 times 2, right? This is 4 times 729. Therefore, this is 36. I got 3, 8, 11. We got 1, 28, 29. We got 2,916. Okay, that is correct. All right. So careful with the computation. Let's go a little bit faster now, yes? Now that we got the hang of it? Yes, Mr. Q, we love this. All right, good. All right. Example 1C and 1D. And by the way, we still are using the commutative and the associative properties. Is that correct? Good. Simplify those, please. Go. Or should I say copy those? Go. Alright, so, by the looks of it, if you use commutative in associative property, we move things around. Q cubed times Q to the 6th times R to the 2nd. This becomes Q to the 9th, R to the 2nd. Is that correct? Okay, on this one, some of you probably at first glance forgot to put the 1 and you made a mistake. Some, I said some. Therefore, if I put all the positives together, n to the 3rd, n to the 1st, n to the -4, n to the 4th, n to the -4, therefore, see what I did there? N to the 0. Yes, we'll get there. And does everybody understand why 1?
Yeah.
Everybody understands why 1?
No?
No, because they just told you to remember, right? That's why I want to get to that part right now. Give me a second. Okay? So for right now, I'm going to leave it like that. Let's move on. Too easy. That one. Go. Example 2C and D. 2C is m times n to the -4th times m to the 4th. And D, we got x times x to the -1 times x to the -3 times x to the -4. Ready? You got 30 seconds. Go. Copy that, please, and go. All right, check with the neighbors, see what they got. All right, m to the 1st times m to the 4th times n to the -4. This becomes m to the 5th times n to the -4th. Are we there? Like I said, for right now, I'm not doing anything with the negatives or 0 exponents until you know why. Does everyone understand? So if you leave it like this for your home play, that's fine. If you already know to do the step that follows, that's okay also. But I just want to make sure I get to the part where we cover those properties and not just because you memorize stuff. And the last one, who got x to the -7? Yes? All right. Home play for tonight is a play sheet. That play sheet has both sides, page 8 and page 9. But I only want you to do page 8, numbers 7 through 18, and 25 to 27 only. Yeah, it's on the agenda, right? You wrote it down? Was it 7 through 18?
It didn't have the page number here.
Oh, that's why I'm giving you the page number. Yeah, page 8 only, yes? So on your way out, the play sheets are in the back. Have a good one, guys. Enjoy your home play. See you guys tomorrow. And for the purpose of the video, I'm going to upload that in a little bit. So I'm going to turn on my camera so you can see the home play. Let's see. Okay, so here's the problems for tonight's home play. You can barely tell on some of them. I don't know if it's going to come out pretty clear. Let me zoom in. Yeah, you still can't really tell. It's numbers 7 through 18 and 25 through 27. I know you can barely tell, but that's the play sheet for tonight. Yeah. All right. Have a good one, guys. Enjoy your home play. Bye.